Hi everyone, and welcome to this webinar brought to you by the Information Lab. Here at the Information Lab, we dedicate ourselves to helping people make sense of data using Tableau and Alteryx. I'm Adi, and I'll be with you throughout this series of web trainings where we'll focus on getting the most value from your geographic data. In this first session, we're going to cover off some of the basics, looking at the fundamental principles of spatial data, figuring out how we connect to this data in Tableau, and creating and enhancing our first map. Now, for all you folks interested in exploring the same data that I'm using, I'll add some links in the description box below this video. Remember to hit pause in the recording at any time so you can follow along if you'd like to. You also need to know that I'm running Tableau Desktop version 2020.1. If you're on a release before 2019.2, some of the features that we talk about won't be available to you. But hey, this is a great excuse to get IT to upgrade you. Now, without further ado, let's get that value add from your geographic data. And we drive value through insight. That's the key term here. We're aiming to increase the speed to insight, utilizing spatial data and maps when they're appropriate in order to get the location advantage. And really, we're talking about location intelligence here, providing analytic and operational solutions across your business, grabbing the spatial data that you inevitably already have around site locations, delivery routes, registered customer postcodes, enriching that with census or demographic or income data or social media presence in order to gain a better understanding of what is happening in the business and why. And fundamentally, for location intelligence, we need to begin with the same core question as business intelligence. And that is, what opportunity or challenge is my organization trying to solve? Some common spatial challenges. Basic context. Where are my stores, my plants, my salespeople? A little more sophisticated, perhaps. Where's my closest competitor? Figuring out a little bit about site selection. What services exist within 5 kilometers of my proposed site or store? And finally, perhaps industry specific. How might environmental factors affect the lifespan or the service schedule of my product? And the more specific the question, the greater the impact it can have on the business. But an important caveat for this, if the question can't be or isn't answered by a map, then you can leave that out of your final product. But in order to be able to make that editorial decision, we need to have some evidence to fall back on. And this is where Tableau really shines. With its code-free drag and drop interface, we can switch things up so easily that it's a rapid process to generate the evidence we need to make those editorial decisions. So let's take a look at an example of that right in Tableau. Now here, I have a data set of traffic monitoring stations in the London area. And with a few clicks, I can get these traffic monitoring stations into the view. Perfect. I can also quickly interrogate particular areas by using the zoom function. Let's take a closer look. Now, what I'm also going to do here is add some base layer context to help my users understand what is going on. Traffic monitoring stations sit by roads, so it makes sense to switch this layer on in the mapping options. So we'll drift up towards the map tab at the top of the workbook. I'm going to go into map layers. And here I can switch on my streets. In this instance, I might choose to select the streets layer completely. Let's perhaps change that color a little, and let's make those dots a little smaller. All right, that makes a little more contextual sense here. Just gives me an idea of where these sites are in relation to other things. So let's zoom back out again to the full data set using this pin on the canvas. Okay, great. Now, if I supplement what's currently in the view with another field from my data, I can get more from the data set. Now, down here in my measures, I have fields that correspond to the counts of particular vehicles. And if I drag one of these into the view, let's go for buses. I'm going to put that on size. And let's resize that slightly. And let's change up our opacity so we can get a bit more of an idea of what's going on. Okay. Within a few seconds, I get more of a sense of that traffic load environment with respect to public transport coverage. And this is kind of confirming my suspicions that we have a dense bus network throughout central London, tailing off as we move into the suburbs. Now, if I swap buses out for HGVs, heavy goods vehicles, let's do that now. I'm immediately thinking about logistics across the core arterial roads in London. That loop we see in the north of London is the North Circular, and also those core arterial routes running east to west across the city. Well, actually, as someone who cycles regularly, really I'm thinking about what routes I might want to avoid when I'm out and about. But you can see that within a couple of minutes, I'm able to assess what could be valuable to my business just through the accessibility of the Tableau interface. And by extension, I'm able to make decisions on what is less useful through the same interface. And that is Tableau giving me the tools to generate the evidence I need to make editorial decisions about my final visualization. That's an incredibly powerful thing. At this point, we're going to step back a little and look at what underpins the whole idea of location intelligence, and that's the spatial data. So let's get into it. For our purposes, there are two main types of spatial data: spatially ready data and spatially enabled data. Our spatially ready data are typically coming in flat files or Excel sheets, or we might have numerical fields for latitude and longitude. Or we may have fields for which latitude and longitude can be generated, like addresses or place names or larger administrative units, like states, counties, or countries, for example. In terms of the data, we don't have a spatial data type here, only numbers or strings, text fields. But those fields are ready to be enabled spatially. And we identify those spatially enabled data by the presence of a spatial geometry, a single column that's used to render the shape of our spatial object on the screen. That may be single points or lines representing a road or river network, for example, or polygons, shapes denoting areas. And some of the file types you may see for these, and those that are read by Tableau, Esri shape files, quite a common file type to see. Can also connect to Esri file geodatabases. MapInfo tab files. MapInfo is another desktop-based GIS software. GeoJSON, which is typically seen in web mapping applications. GPX, which is GPS-based data, plotting routes or waypoints. And if you use Strava, this is what plots your route, either on the screen or on your device. Then KML or KMZ files, that's keyhole markup language. And this is the file type we can derive from Google Earth layers. Now, since Esri shapefiles are the most common spatial files that we'll probably come across, still by quite a long way, it's important to flag the file structure up now and keep it in mind always when dealing with Esri shapefiles. And the files themselves typically come zipped up. And when you extract the files from that zipped up package, you'll get anywhere between 3 and 7 objects come out. Now, in the description, I've linked a blog that details what each of the files represent. And you can read that at some stage if you're interested. But the key take-home message is you must keep the .shp extension, the .dbf, and the .shx together. Don't delete any of them. Don't move one to another location without the others. If you extract your shapefile and find you have 7 objects, just keep them all together. But the core 3 are absolutely critical in drawing the shape and feeding in the attributes of that shape, what it is, what other characteristics are linked to it, for example. In the image on the slide, you'll see that I also have a PRJ, a projection file. But again, if I want to move one of these objects, I'll move them all to the same place. And that's absolutely key. Now, with all of that in mind, let's go back into Tableau and take a look at some data and figure out what's happening and how best to represent the spatial data that we've got. First off, we'll look at how to connect to data in Tableau and render it on a map. So let's jump back into our Tableau workbook. Now, in this first example, we're back looking at the locations of traffic monitoring sites throughout London. If we take a look, let's give this a little more space. If we take a look at this file and just investigate its file type, you can see that this is coming in as a CSV, flat file. So this is spatially ready, but not spatially enabled. And you can see here that we've got fields in the measures part of the data pane called latitude and longitude. Now, there's nothing special about them at this point. If we take a look at the data source, you can see that they're just decimal point numbers. But Tableau says, hey, you've called this field latitude, so there's probably some geography about it. So I'm going to give it the globe icon in the same way that I give a date, the calendar icon, or a string, the ABC. Now, when I go back to put latitude, longitude, effectively YX data in the view, what's actually happening is a scatter plot with a background image. Let's go ahead and do that. So I'm going to double click latitude and longitude. And at the moment, I have one dot representing the average or the mean center geographic location for all the data. And I can burst this dot with a dimension to get the granularity that I want. Now, each of my monitoring stations has an ID. So I'm going to use that to burst my dot. There we go. And we can also take a slightly different approach here in terms of getting our points on the map. I'm going to clear this worksheet and begin again. What we can do is convert the latitude longitude fields to dimensions by dragging them up to that area of the data pane. So let me go ahead and grab latitude and longitude. I'm going to drag them up to dimensions. There we go. And if you remember how Tableau behaves with this type of dimension, it isn't going to aggregate these fields when we push them into the view. So we'll automatically get a mark for each data point. So let's go ahead and plot that. Great, so we didn't need to use an additional dimension to burst anything there. We have 1 point for each data point in our data set. Now also notice here, at the most detailed level, that we're looking at discrete objects. These are individual monitoring stations. So from a spatial perspective, this is point-based data. And Tableau will, by default, represent this as a circular dot. But for Tableau, that's just the choice of mark type. And we can alter that using the shapes option and have geographic point data displayed using a variety of different shapes or symbols. So if you go ahead and click this little caret in the marks card, I'm going to pop down and select shape. You can see I automatically change from having a filled dot to having a halo with an empty space in the middle. And I can choose to represent this geographic point data with a different shape if I see fit, if that enhances what I'm doing. Now, as it happens, a filled dot is really what I want in this instance. So I'm going to return to that. I might change my color slightly, maybe change the opacity a little, or change the size. Perfect. Now what we're going to do at this stage is look at a slightly different data set that's going to help illustrate the other ways in which Tableau will put objects on a map. I'm going to go ahead into my next worksheet. We're making school locations active. So I have school locations. Again, they're here in London. I've taken some time to arrange my fields into folders. I have address details for my school. I also have broader attributes about the school, the gender, whether it's single sex, mixed, as you can see here. Other elements, whether we're looking at primary schools or secondary schools, or junior schools or high schools, the school name, the status, so we're able to assess whether we have schools that are open or closed, or those that might be closing imminently. Now notice that we don't have fields called latitude and longitude in this example. So Tableau hasn't been able to intelligently allocate the globe symbol, and it won't automatically send in a base map when we try to plot these points. In this case, Tableau is trying to generate latitude and longitude from one of the address fields in our school data. Here it's recognizing postcode. That's something that we'll come back to a little later. As I was saying, we don't have explicitly latitude, longitude named fields, but actually I know from the data that it's the fields X and Y. They're the ones that we want. X and Y are perhaps less helpful to newcomers to spatial data, but they're often used to denote longitude and latitude fields. So to avoid any confusion here, it's probably best that we go ahead and rename the X and Y straight away. And that's going to make our interaction with the spatial functions in Tableau much more straightforward. So let me go ahead and right click on my X field. I'm going to rename that. X is longitude. Lines running around the world. Y is latitude. Lines running north and south. Now still, Tableau hasn't understood what we want. So we haven't, just by renaming those fields, generated that globe icon. But that's fine, because if Tableau hasn't understood that, we can tell it that this is what we want. So what we're going to do in this case is right click on each of the fields and assign it a geographic role. So let's go ahead. It's geographic role. You can see the variety of geographic roles that it's possible to assign. In this case, we have latitude and longitude. So I'm going to select latitude. Notice immediately the hash sign turns into a globe. And I'm going to do the same for longitude. Let's grab that geographic role. Perfect. And again, once we have latitude, longitude, we can put those into the view. Here I'm using the burst, the dot approach. So I have latitude and longitude showing me the average location for my data set. Each of the schools has an object ID. So I'm going to go ahead and drag that onto detail, and that is the field that I'm using to burst my dot. So from here, we're going to get one dot moving to lots as we get all the schools that we have in our data set. Perfect. Now, so far, we've been dealing explicitly with specified latitude and longitude fields. But even if I don't explicitly have those fields, I can get Tableau to generate them using its internal geocoding engine. What I'm going to do is move on to this worksheet. And also we're going to have a look at this data set, city locations. Now again, this is a flat file reading in, a Microsoft Excel file. We don't have latitude, longitude explicitly expressed in the data, just have some locations and then a field that represents a number of people. Now I know that even though the locations field has come in as a string, I know that it contains a list of cities. I'll just show you that it does if we have a look in the data source. Here you can see a list of cities that are in the UK. Now, Tableau hasn't correctly assigned that with a geographic role, but I know that it has this in its internal geocoding engine. So I'm going to tell Tableau that they are cities so that it can match them effectively with its internal reference sheet. And then it will generate me latitude and longitude for these cities. So I'll right click again. I scroll down to geographic role. This time I'm choosing city because that's what the locations are. Now watch, in the measures pane, we will get latitude and longitude generated. Almost like magic, there they are. And we can go ahead and plot those points. So I'm going to double click on locations. And what we get, a range of cities across the United Kingdom. Now at this point, my attention is kind of piqued because I think that my underlying data set is complete. Tableau's having trouble identifying one of the locations. So what I'm going to do is left click on that, and I have some options for what I'm going to do. I could just exclude that point, but I know that it should be there. So I'm going to try and troubleshoot this. I'm going to go into edit locations. Now at this stage, we're working top to bottom, and sometimes we might have a mismatch in country or region, and that might confuse Tableau. So if our country or region in this case was set to the United States, Tableau might have a problem with picking out where these cities are. Here it's set to the appropriate country, the United Kingdom. I don't have a specified state. I know that my cities are contained within the locations field, so all of this configuration is correct. I then move down one, and I see that the city causing me problems is Hull. And what's going on here is, if I type this in on the right-hand side, you can see that Tableau is having difficulty identifying which Hull to put in the view. We have Bishop's Hull, Kingston upon Hull. We need to be more specific. In this case, I am specifying Kingston upon Hull because that's the city that I'm referencing. So I can just pick that from the list. And we're going to OK that. And you can see that my unknowns have disappeared, and I now have my full data set represented on the screen. So it's quite useful if you get unknowns or errors, just to interrogate those and see how you can troubleshoot. Perfect. Now, so far, we've been looking at spatially ready file formats. Now, to add spatially enabled data, we follow the same procedure as connecting to any data source. We just select a different thing. So I'm going to go ahead into this worksheet. And what I want to do is add some spatial data. So I'm going to go ahead and click on the Add Data button. I'm going to look down for a spatial file this time. And then I'm going to navigate to a location where I have some shape files. You can see the SHP extensions on show here. That's the file type that draws the object on the screen. So that's the one that we'll be able to select. Though do remember that we have to keep them all together. That's essential. I'm going to choose London boroughs to read in, and we'll take a look at the fields that pop in. So over to the right-hand side, if we took a look at those fields, you see immediately that we already have a geometry. This is a natively spatial file. Looking at this data source, we can see that the geometry type is polygon. So when I render this on the screen, I'm expecting to see shapes or areas. Let's test that out. Here we go. I'm going to double click on the geometry. Perfect. So I'm looking at boroughs of London. I'm just going to pop their names on the list, and let's give this a little bit more definition. Perfect. So each of these shapes that's rendered on the screen, that is an area representing a borough of London. Perfect. Well, let's try that again. This time we're going to have a look for some line strings. We're going to have a look at representing roads. So again, I'm just popping into a new worksheet. I'm repeating the same process. I'm going to add some new data. I want to add a spatial file this time. And I'm going to be looking for some road-based data. So I'm going to select that out. And I'm going to go for some road links. And this is a slightly richer data set, so we have many more columns. But if I scroll all the way over to the right-hand side, you can see, again, natively spatial, because our final column is a geometry, and the geometry that is there is a line string. That's what we're expecting. That's an appropriate way to represent roads. Therefore, when I plot this geometry, I'm expecting it to render as lines. So let's go ahead and test that again. Okay, perfect. So I've got a selection of lines. It looks like a road network. That is a sense check. All looks good. So there they are. And these have been shape files coming in. So you notice I selected the SHP file when I was searching for data. But you might also remember that I mentioned shape files are common, but they're not the only spatially enabled file types we have access to in Tableau. We're going to look at a couple more in this webinar. What I'm going to do now is have this new worksheet open. I'm going to go back and add some more spatial data, same approach. Let's look for a spatial file. And let's navigate to my data sources. Okay, so what you see here is the icon for Google Earth. And what I've done previously is sketched out a quick area, a polygon, in Google Earth, which is free to download. I saved that shape as a .kml file, and I can now add that into Tableau. So I'm going to click that, and then let's open that file. So you can see, again, it's a very basic file. There's not a lot in here, but we do have a geometry, and the geometry is saying polygon. So when I put this onto my map, I want to see an area, I want to see a shape. So let's go ahead and make a little map to demonstrate that. Just going to pop that in. Let's make some changes so it's more clear when I load this in. The minute can't really see an awful lot. It's successfully loaded into the view, but I know this is Greenwich Park and Blackheath, but my map's not really showing me a lot at the minute. So what I'm going to do is just change the layers up. I'm going to go for map, background maps. Let's call this, let's go for outdoors. Okay, that's slightly better. So I have much more context in what I'm trying to show. You can see this polygon that I've drawn a little bit rough around the edges. I haven't entirely traced the exact outline of Greenwich Park and Blackheath, but it's close. It's there or thereabouts. And you can see if I scroll out a little bit, I've got a nice little custom shape sitting in my canvas, and that is on top of a default base layer in Tableau. So I'm starting to progress a little, mix and match what's default and what's more custom. Now, the last example that we're going to look at today is a GeoJSON file. So let me pop into this worksheet, and again, repeat the process. So we'll add some data. I'm going to scroll down, look for a spatial file. And again, you can see by the extension types, I have a KML, some GeoJSON files. I'm going to look for this Eckert-4 GeoJSON. Now, GeoJSON stores spatially enabled data. It's based on the JSON format. And when we read this in, you can see that the geometry type that we're dealing here with is, again, it's polygons, it's areas. And I'm going to bring this into the view, but you'll notice that something special is going to happen. So watch when I double click. And we just wait for the background map to load in. Let's put that back in. Okay. Now this GeoJSON file that I've read in doesn't sit exactly over the top of the default base map in Tableau. Now I had that switched off. I turned it on to show you that they don't align. I'm now going to wash that out again just to make things a bit more simple to look at. Now what's happened here is that we have two different projections in operation. One that's the Tableau default, and the other that's the system that the GeoJSON file is encoded with. And the ability to hack our way out of the Tableau default is incredibly useful, and it's something we'll talk about in a later episode. And to give you a little flavor of what we can do, here's a finished example. I've used the same GeoJSON base map, but I've supplemented that base map in the projected system with some population data so that I can display proportionally sized dots representing major cities across the world. And with that, we've gotten to a stage where we can effectively get content onto the map, whether that's latitude and longitude explicitly, whether that's asking Tableau to reference its internal geocoding engine to help us put objects on the map, or whether it's us going a little bit off-road and generating our own custom spatial content. Now, as a really quick exploratory tool, just putting things on a map, that's superb for answering the basic questions, where are our data points? But typically, the business questions won't end with, where are the objects? In fact, just plotting the objects, as we've done here, we're often driven to ask more, generate more analytical questions. So we want to push further. Or next time, we will push further. We're going to move on from where are the objects type questions to how many objects do we have in each location. And we'll need to look at how we deal with aggregation in spatial data. Until then, keep exploring. And feel free to reach out to us here at the Information Lab for solutions to your data challenges. Stay safe, and I'll see you all next time.